Okay, good morning. Today we're going to discuss something that's very important in regression analysis. Once you have come up with a model, which we have done in the past sessions, if you recall, guys, we were using the wage, but let me flash that a bit. We were using the wage data, and we hopefully we learned so many things already about regression. We have learned to load the data in R. We have learned to do simple linear regression. We have learned how to do multiple linear regression. We have learned how to compare models. Okay, we have learned how to determine if model 1, which is a restricted in the sense that it has fewer variables, is better than model 2, which is the unrestricted model. Okay, it's very important to determine whether adding a variable is statistically better than just having fewer variables. So we learned about that using ANOVA. We learned how to interpret the output in a multiple linear regression. And also we learned how to use OLSRR, okay, because we said that when you have multiple regression and you have several predictor variables, and when you generate the results and some of them are not significant, we don't just stop there. We do what we call stepwise regression to arrive at the final model. And the OLSRR package is a very powerful package that allows us to determine the final model, okay? Either based on p-values or based on AIC. So the next step, class, the next step is to determine if our model is consistent with the assumptions of classical linear regression model. So we call that regression diagnostics. So we'd like to see if it violates linearity, violates multicollinearity, heteroskedasticity, or homoskedasticity, equal variance. So these are the things we'd like to check or to diagnose and try to address, okay, if we can, these violations of the classical linear regression model. So by way of review, let's take a look at the assumptions again. You have linearity, which means that the X and Y. So there are two things that we looked about linearity, right? Linearity of the among the variables, linearity in your dependent variable and independent variable. We would like the dependent variable to be linearly related to your independent variable. Otherwise, if they're not linearly related, let's say they are more quadratic in relationship or polynomial, then it will not be a good idea to use ordinary least squares, okay? We will not be using LM. We will not be using linear model, but rather what's used there is what we call GLM, generalized linear model. Okay, so linearity. The other linearity, by the way, if you recall, is linearity in parameters. Okay, which is not actually tested here anymore because we are really using betas, the parameters, to be linear. We're not computing for beta squared or beta cube or square root of beta or log beta. Okay, the variance should be equal, okay, across observations. We don't want the variance of the residuals. Okay, so notice that in the diagnostics, many of the tests are as regards residuals. Okay, so for example, independence, which means that the residuals should be independent of each other. And we have learned in the past, in the past lessons, that this is more a problem with time series rather than cross-sectional data series. Normality also, the residuals should be normally distributed. And let me add here another, okay, no, never mind. So we'll just discuss it as we go along. Okay, the first step of this regression diagnostic is to inspect the significance of the regression beta coefficients as well as the R squared that tells us how well the linear regression model fits the data. Okay, so let me go over this one, guys. Okay, linear regression model makes assumption that the relationship between your independent variable or predictor X and the outcome variable Y is linear. Okay, so we have been discussing this in the past. Let me once again go that. Diba? Ito yung Y natin, ito yung X. We don't want that the relationship looks like this guys, this type of a relationship will not be good using OLS, ordinary least squares. Okay, so there's a better method to use if the relationship is like this. We would want the relationship to rather be like this. Okay, so there's more a semblance of a linear relationship. So that's what we mean by this one, guys, linear relationship. The relationship, of course, could be polynomial or logarithmic. It could be going this way. Let's use a different format for this. It can be going this way. Sorry. Para may pattern na may pattern siya na polynomial, no? Okay, or quadratic, as I said a while ago. So we know, guys, that could be the relation between your independent variable X and your dependent variable Y. However, if that's the relationship, guys, then OLS will not be a good model to use in predicting or establishing the relationship between your Y and your X. Okay, additionally, the data might contain some influential observations or outliers. So we'll discuss this later on, depending kung ma-reach natin yung point na yun. Okay, so when you say influential observations, okay, for example, we might have, let me use a green. Okay, so you have your data here, and then there could be a data somewhere here, or here. Okay, let's assume that this data is not an error. There was no error in recording this. It just so happens that this is that data. Okay, so there's a possibility that this is an outlier. So there are ways in order to determine whether a particular observation is an outlier. Okay. There are different ways to determine this, but the most popular one is the two-key approach, which you already met, okay, in your basic statistics, which we're also going to look at later on as a review. And the outliers are not really well, they're relevant, but much more relevant are what we call influential points. Okay, influential points are outliers. Okay, but not all outliers are influential points. Influential data points are those, the presence of which greatly affect your model. So remember, our model is Y is equal to beta null plus beta 1x plus beta 2x, etc. The outliers does not necessarily affect the values of our betas. But the influential points are those that really affect the value of the slopes, the parameters. So that means this is very, very important because the presence of influential data points will affect the interpretation of our model. Okay, so clear so far, guys? Paki-chat naman please kung clear so far. Any questions? Okay, thank you, Samir. Thank you. You, how about the rest? Okay, good. Salamat, guys. Appreciate your feedback. Kulang pa rin yung feedback. Okay, how about the rest? Sana 100% tayo, guys, kasi konti lang naman tayo. 5 pa lang how about the others? Yan. Thank you. Okay, sige, let's proceed. Okay, so clear ko na muna to. Hihirapan akong i-move tong mouse nito. Okay, so it's important that we check the diagnostics. We do diagnostics testing for the regression. Okay, so that we'd like to determine if the assumptions of our linear regression model are met or not. However, guys, may caveat lang ako sa dulo. Let's go to the bottom part. No? I included here a certain okay, managing our expectations a bit. So, nagagaan lang siya. Take a look at the bottom part, guys. May note lang ako doon ng konti, no? Nagahang siya. So, importante yung regression diagnostics, but we can take it with a grain of salt also to a certain degree. Just a moment, hang yung pause ko muna recording, guys. Remind me, please. Sayang yung minutes na. We're going to make use of the package Datarium. As I mentioned a while ago, guys, you can check this Datarium sa console natin. And it will give us information about the package. It's still loading. Or another way is just to go to the packages here, because sometimes this takes quite some time, and then type Datarium. Dito natin hanapin yung Datarium. But hopefully my R will work. So while waiting for that, guys, let me just run this. Okay, ito na siya, no? So if I click this, Datarium, there. So we have here data bank, Datarium, for statistical analysis and visualization. So hindi naman siya gaano karami, no? Ito lang siya, no? So these are the data sets that come with the package. Yung ibang packages, guys, wala siyang functionalities, no? Ang kasama lang niya, data lang yung mga kasama niya. So let's check the description file. Ito lang yan, no? Contains data. Okay, nawala siya. Nawala. Okay, anyway. So we will use the one data set there, the marketing data set. And so let's use the data function data, quotes, marketing, and then comma, package is equal to Datarium. Okay, okay lang naman, guys, na hindi isama to, yung package na to. Kasi malalaman naman ni R kung saan galing yung data set na yun. So let's view this. Okay, so this is the data set consisting of 200 entries. Okay, you have these variables, YouTube, Facebook, newspaper, and sales. So mukhang obvious na ang i-regress natin dito si sales on YouTube, Facebook, and newspaper. We'd like to regress, we'd like to see how related your sales is to these three variables. But let's start first with a simple linear regression. Okay, so let's just quickly look at the data. Ito yung first six yan, no? So, and then yung structure. Ano ba yung structure ng marketing? It's a data frame with 200 observations, lahat numerical. And then summary, this will give us the 5 number summaries. First quartile, second, third, minimum, and maximum, and also the mean. Okay, 6 number summaries. Okay, so sales ranges from 1.92 to 32.4. Okay, and then the mean is 16. The median is 15.48. So medyo skewed to the right siya, no? Kasi mas malaki yung mean sa median. Also, the newspaper, si Facebook, medyo pareho lang. And then, ito naman si YouTube, medyo skewed to the left. All right. So, we know how to do this already in building a simple linear regression. Let's first do a simple linear regression where sales is regressed on YouTube. Okay. And then we call it FIT1. So summarize natin. We won't really go here that lengthily kasi alam na natin to, no? And YouTube is a significant predictor of sales there. 3 stars, which means significant at 0.001 level of significance. Okay, so our equation here is sales is equal to 8.44 plus 0.047 times YouTube, okay, which means that for every 1 peso increase in YouTube ads, there's a corresponding around $0.047 increase in sales. Ceteris paribus. 8.44 is the is the value of sales if you're not going to invest in an ads in YouTube. Okay, overall goodness of fit, guys, it's okay. The null hypothesis is beta null is equal to beta 1 is equal to 0. So we reject that null hypothesis. Okay, so I'm going through this quickly, guys, because we have, this is just a review. Adjusted R squared is around 61%, which means 61% of the variability of your dependent variable Y, which is sales, can be explained by your independent variable YouTube ads. So 60%. Okay, so we have done this in the past, and this is just a quick review. What is contained in your regression output? Ito, di ba? Yung coefficients, yung residuals, yung fitted values or predicted values, and others. And you can call this out. You can call this out by sorry. You can call this elements here, or you can just in the output. You can just click fit1, this one. If you click this, then it will show here in our tab here. And then the values are actually here. Coefficients, for example. Yan, diba? 8.43 at saka 0.047. Yung residuals, marami to. 200 lahat yan. Okay, etc. So these are the elements, guys, of your regression output. I mean, in R, okay? So, for example, if we want to get the coefficients, because coefficients is an element in your regression output, we can identify the model and then $coefficients. This will give us the intercept and the slope of YouTube. Okay, for the head of the residuals, so here, we'd like to print the residuals. And then, yung first, ano lang, no? Rinound kasi natin to round ng 3 decimal places. Head will give us just the first 6. So ito yung mga residuals natin, yung mga error terms. And then, yung fitted values natin, pagsabay natin to. Ayaw. Nangyari. Ay. Yan. So, yung dalawang, ito yung una, guys, yung residuals, ito yung error terms. Ito naman yung predicted value using the model. Okay, this is just a review. Any questions so far? Again, guys, any questions? Paki-chat naman kung clear tayo so far. Any clarifications? Okay, thank you. All right. Let me close this. Okay, so here are just some questions. Again, by way of review. Okay, hello guys. Nawala ba ako?
Nawala po, sir.
Wala. Ayun. Okay, so I think we're still continuing recording kasi ano pa rin, pause or stop. Okay, good. Okay, talagang either yung machine ko yung may problema o yung connectivity or minsan yung power. Yun ang mga na-experience ko in the past few days. Okay, so ito guys, sinulat lang yung yung let me rerun this. Sinulat ko lang dito yung model natin. Okay, hindi nag-run yung LaTeX. Okay, anyway, sinulat lang siya no, in LaTeX format. All right. Now we go to the main lesson today, yung analysis of variance. Okay, so yung predicted values natin, guys, are of course based on the values of the model. Kasi di ba dinetermine natin kung ano yung intercept, ano yung slope ni YouTube, which is our predictor, which is our independent variable or predictor variable. So ang model natin 8.439 plus 0.047537 times YouTube. If we substitute this with the values of YouTube, di ba?
Sir?
Yes?
Di po naka-share screen.
Hindi naka-share screen. Okay, sorry. Okay. Naka-share screen ako. Okay na?
Yes po, sir. Thank you.
Thank you, thank you. Guys, pag may problema, sabihin sa akin kaagad kasi hindi ko nalalaman minsan biglang, di ba? Biglang nawawala ako tapos ano. So you have to immediately inform me para ma-address ko kaagad. Okay, as I was saying guys, yung model natin, our sales is equal to 8.439 plus 0.0475 times YouTube. So we can have a predicted value of sales for each of the individual. Kasi ito yung ano natin, no, yung model, ito yung data natin. So marketing, ito siya. Yan, di ba? So bawat isang observation, may value ng YouTube, Facebook, newspaper, tsaka sales. So if we substitute yung YouTube na to, 276, dun sa model natin, magkakaroon tayo ng predicted value. Okay, so what is the value of sales based on our model? But we have the actual value of sales, 26.52, di ba? So if we get the difference between the actual value and the predicted value, then we will have what we call the residual, yung error terms natin. Yung difference between your actual value and then the predicted value. Okay, so let's go here. All right. So dito, we're going to draw, guys, predict the model, yung regression line natin. I-drawing natin, tapos i-drawing din natin, i-superimpose natin yung ano natin, yung actual values. No? Okay, so what are we doing here? So we're going to create an object, create sa marketing, guys, sa marketing data natin, i-add natin yung variable na residuals. So I hope you understand this, guys, no? Yung marketing data natin, dollar residuals, it means that we're going to add a variable called residuals, no? Tapos, ano yung value nito? I-round natin from the residuals of fit, no? So pwede to residuals ng fit or pwedeng fit, pwede yung ginamit natin kanina, fit 1 tapos dollar residuals, no? Pareho lang yan. or ito, residuals ng fit, tapos 3 decimal places. Sige, let's first run this and check our marketing data. Okay, let's check our marketing data. Notice guys, meron na tayong predicted value. Meron na tayong residuals dito. Okay? So we now have, in the marketing data, we now have added the residuals. Ito na siya. Of course, pwede din natin i-add sa predicted value, no? But let's see what I did here. All right. So ito din, in-add natin guys, no? Marketing $sign predicted, which is round natin to 3 decimal places, yung predict ng FIT1. FIT1 is a regression model. So let's also do this. And you can now see that we have now your predicted value. Okay, if you check guys, if you check predicted value, okay, sales less predicted value is your residuals, di ba? Yung difference nila, yun ang residuals natin. Sales 12.48 less yung predicted value 10.98, that's your residuals 1.5. Okay, so we have now we were now able to introduce to our data set yung residuals at saka yung predicted. Now, ang gagawin natin dito, guys, this is what we call the pipe operator to, no? Hindi natin na-discuss to, but suffice it to say, guys, that this comes from the package. Actually, nanggaling muna yan sa package sa mag-read-r na ginamit din sa dplyr. Di ba, in-install natin si dplyr. Ito yung purpose nun. Kaya natin in-install si dplyr kasi gagamitin natin itong pipe operator na to, and in particular, yung select. No? Yung select. Okay, so let me just explain what this code is. So, ibig sabihin nito, guys, from the marketing data set, okay, ito yun, no? Gagamitin natin yung marketing data set. Tapos, ito guys, ito, ang ibig sabihin yan, and then, okay, and then. Yun lang ibig sabihin yan, and then. So, may gagawin din daw tayo from the marketing data set, and then, magse-select tayo. Select. So, itong select, guys, it will just filter. It will filter whatever you want from the marketing data set. So, sabi ko, select natin si sales, si YouTube, si predicted value, at saka si residuals. Okay, so in other words, guys, ito, gagawa lang siya ng YouTube, sales, residuals, predicted. Yun lang ang pipiliin niya. No? So, we can do this. No? Gawin natin M1, alt minus. Yan. So, let's create this object. Ay, hindi. Sorry. Huwag muna, kasi may head dito eh. No? I'm sorry about this. Kasi yung dulo, guys, sabi ko, get the head, no? Pwede rin siguro. Okay, sige, let me check. But I'm not sure. But let me check. Sige, mag-create tayo ng object na M1. So, galing siya sa marketing, tapos pipiliin lang niya yung apat na variables, no? And then just print the head, yung first six nito. So, let's check. Okay, run natin. Okay, error. Ayaw niya, no? Ayaw niyang mag-create ng object tapos kukunin pa yung head. So, tanggalin muna natin to, guys. Let's remove M1 first. Remove M1. Ito na muna, no? Gagawin niya, get marketing data set. Piliin lang niya. Select, guys, will select variables. No? Yung isa naman, filter, will select rows. Ibig sabihin, yung observations yung pipiliin niya. Kung ilan. So, sales and then head. So, let's run this. This will not work. This will now work. Okay. Bakit? Could not find the function. Okay. Nag-work sa inyo, guys. Ibig sabihin, na-load nyo na si ano. So, dapat i-load ko to. Hindi ko yata na-load. Load ko na nga lahat. Guys, feedback please. Nag-work ba sa inyo?
Yes, sir.
Amin po nag-work.
Ha? Nag-work?
Yes po.
Okay, good. Pati yung M1 nag-work? Kasama yung M1?
Yes po, sir.
Okay, so sorry, no? So I gave the wrong assessment because hindi ko pa na ano hindi ko pa na-run yung ano yung packages, yung library. Okay, so let me go back here. So balikan ko tong M1 na to. Nag-create lang ako ng panibagong object. Okay. So magandang gawin to guys kung gagamitin niyo pa ulit tong dataset na to. Kung hindi naman, then pwede nang hindi niyo na gawin yun. Nagka-M1 dito guys. Kaso yung M1 na yan guys, 6 observations lang yan ha. 6 observations lang yan. So, mali pa rin ako kasi linagay ko yung head, no? So, tanggalin muna natin to guys. Kasi M1 natin, 6 observations lang kasi hanggang pinasok natin si head eh. Ibig sabihin, 6 observations lang ipapasok niya. Okay, so let me run this. Okay, so ito nga yung 6 na observations. Okay, thank you for the feedback. Okay. So, but if I want to create an object with all the observations, tanggalin natin to, tapos mag-M1 tayo dito. No? Okay, so you can just, sige, pakita ko na lang para just for discussions purposes, M1, alt minus. So I created this object, pero hindi ko na sinama si head. Para hindi lang yung first 6. If I run this, and tingnan nyo, yung M1 ko guys, nagbago na dito sa objects. 200 observations na siya. Kanina 6 lang eh, kasi linimit ko lang dun sa head, which is the first 6 observations. Okay, is that clear guys? Clear yon yung difference nito at saka nito? And also the pipe operator. Okay, paano niya nga pala tinipe itong pipe operator, guys? Sige, yung first question muna, guys. Nakuha niyo yung difference nitong line na to at saka ito, guys. Paki-chat please kung okay tayo. Would appreciate immediate feedback from your end. Okay, good. Good. How about the rest, guys? Nakuha ba? Okay, thank you. Now, of course, ito pinakita ko lang to, no? Which will be useful if you're still going to use M1 sa mga succeeding na mga code chunks. Kung gagamitin pa rin si M1, okay lang yun. My next question, guys, is how did you type this? Did you type that as is? Guys? Did you type the pipe operator as is, yung percent and then greater than, and then percent? Feedback, please. Did you type it as is? Okay, so may shortcut dyan. Hindi ko pa pala sasabi sa inyo. Control-Shift-M, Control-Shift-M. Yan ang shortcut. Type nyo Control. So makyata command. Control, Shift, and then M. So that's a shortcut for your, ang tawag dyan guys, pipe operator. Okay? Pipe operator, which means and then. No? So, parang ito yung representative na phrase na and then dito sa R. Okay. So let's now go here. I-plot natin guys, ang medyo mahaba to, no? Itong code chunk na to. So we don't have time guys to discuss this in greater detail. Kasi hindi naman tayo hindi kayo nag-FINTSAR sa akin. But this is a function of the ggplot2 package. So ggplot2 package is a very powerful package for data visualization. So I'd like to encourage you guys, ang dami naman tutorials on ggplot2. No? That's something that really could help you sa sa data visualization, which is a very important aspect of data analysis. Okay, so pakita ko lang ng guys, yung explain ko lang briefly yung code. So here we're using the ggplot function, we're using the marketing data set, and then dinidefine natin kung ano yung x-axis natin at saka y-axis. AES here means aesthetics. No? So ito yung ginagamit para i-define kung ano yung parameters ng plot natin, yung x-axis at saka y-axis. Ang maganda dito guys sa ggplot is that you just add layers. No? Katulad nito, nagpa-plus tayo, plus. So pag rinan natin to guys, so let's just try to run this. So go to this line and then run it. Okay, notice nyo guys na ano nangyari. Did something happen? Wala. Wala nangyari. Dinifine lang kasi natin yung nag-run pa siya. Okay, diba wala nangyari, no? Kasi hindi pa natin dinefine kung ano yung layering ng ng mga plot mismo, no? So if you notice guys, ito mga plus, 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 plus. Notice nagpa-plus, plus, ay, nagtan na siya. Sorry dapat. Okay, X ko muna. Rinan niya lahat, no? Pero kung ito lang guys, yung nasa code chunk natin, kunyari, copy ko to, Control C, and then Control V. Pag rinan ko to, okay, walang mangyayari guys, ito lang siya. No? Dinify lang natin kasi kung ano yung y-axis at saka kung ano yung x-axis. Okay, that's what I was meaning to say a while ago. Now, if you add a layer, kunyari ito, geom smooth, no? Method is equal to LM, standard error is equal to false, color is equal to light gray. So ipapakita niya dito guys yung LM natin, yung linear model natin, di ba? Ito yung regression line. No? Tapos maglalagay lang tayo dito ng segment plus, no? Plus a segment, okay? I-define niya kung hanggang saan yung x-axis at saka yung y-axis. Maglalagay tayo ng color, ng size, ng jittering. Okay, don't mind na lang this guys, no? Kasi alpha dito yung jittering. Tapos plus. Notice guys, yung plus nasa dulo lagi, no? Hindi siya pwede sa first, sa beginning of the line. And then naglagay tayo ng geom point dito. I-geom point natin yung residuals, no? Plus maglalagay tayo ng scale color, okay, black at saka red. And then dito may theme lang. So please don't bother about the many aspects of the plot kasi it will take really time and mauubos yung ano natin. Sa FINTSAR ko guys, ano kami nito, mga 5 weeks kami ng ggplot. Okay, but I'd like to encourage you guys kasi marunong naman kayo ng R. So pag mag-ano kayo ng tutorial ng ggplot2, if you're really interested guys in honing your skills, which you should guys, which you should, I'd like really to encourage you. Take some time, invest in some time to learn ggplot2. And you'll be glad you did guys, that kasi very powerful ang ggplot2. So if I run everything here, makikita nyo, naran nyo na kanina to, no? Take a look at the plot. Okay, medyo nag-warning lang siya dito. Pero nag-run kanina, yung scales daw is deprecated. Use scales is equal to none. So, asan na yung scales ko? Sige. Scale color. Guides, isang guides. Okay. Ito, sabi niya, guides. Ang ibig sabihin guys, ang deprecated, hindi na ginagamit, no? So sabi niya, instead of false, gawin ko raw none. So palitan ko siya ng none. May quotes daw. Yan. Okay? So I just followed the instructions here. And then I'll run this. Okay, so ito yung plot. Okay, hindi natin kaya guys i-plot yan sa Excel to. Siguro pwede rin. I haven't tried but it will really take time. Okay. What do we have here guys? Ito yung plot natin ito yung regression line natin. Ito yung model natin. Sales is equal to the intercept plus yung slope ng YouTube. Ito. And then, what do you have here? Yung mga points na to, guys, these are your, ano yung mga points na to? These are your actual points, no? Okay, some points are very close to the line. Some actual observations are close to the line. Some are very far from the line. So itong line na to guys, these are your residuals. Yan, yung vertical line na yan. So, mini-measure siya, no? Diba? In fact, ang OLS talaga is all about minimizing the square of these observations. Why do you need to use the square of the observations? Kasi pag sinum up natin yung mga residuals na to, it will be equal to 0. Okay, so wala tayong information makukuha doon. Kaya what we do is to get the square of the residuals. And that's what we minimize, yung square ng residuals na yan. Alright? You can see how powerful the ggplot2 package is. Okay, any questions dun sa regression line, guys? Feedback, please. Any questions on regression line? Okay, good. Thank you. Okay. Now we go to the regression. In R, you can easily augment your data to add fitted values and residuals by using the function augment from the Broom package. Okay, linoodan natin si Broom package. So we're going to create this object, model.diag.metrics, and then from the Broom package, we're going to use the augment function, and i-augment natin yung fit1. Okay, and then we're going to print the first 6 observations ng object natin ng model.diag.metrics. So let's run this. Okay, now take a look at this. So meron na tayong panibagong object, model.diag.metrics, which consists of sales, YouTube, your fitted values, your residual values, your dot hat, sigma natin, Cook's distance, and standard deviation ng residuals. Okay, hindi mo natin i-discuss kung ano yung mga to, no? Pero but suffice it to say, guys, that nagkaroon tayo ng object, ito, model.diag.metrics. When you click this, click natin to. Okay. So ito yun, no? Yeah. Andito si dependent variable natin, si sales. Andito din si YouTube. Ito yung predicted value, fitted value. Ito yung residual value. Okay? So ito, Cook's distance, this is used sa, ano guys, later on sa influence. Di ba mention ko kanina? The influential data points. ginagamit natin tong Cook's distance to determine if a certain observation is an influential data point. Remember, an influential data point is very important because it may or may it has the capacity to affect your model, the value of your parameters, yung mga betas natin. Okay, so let's go back here. So this will be used, guys, as part of our diagnostics. No? Okay, so ito guys, no? Ito yung description ito. That hat values. This is used to detect high leverage points. Okay. So tatlong measures, guys, yung nakikita natin dito. Outliers, leverage points, influential points. Okay. So there are distinctions between them, okay, which we're going to learn as we go along. Then we have here the standardized residuals. Ito yung residuals divided by their standard errors. Cook's distance used to detect influential values, which can be an influential value, guys, will always be an outlier or a high leverage point. Lagi yun. But an outlier will not necessarily be an influential point. Okay, a leverage point may not necessarily be an influential point. But an influential point is always both an outlier and a high leverage point. Okay. So inulit lang dito yung yung assumptions natin ng regression. Okay? We should check, sabi nga natin we should check whether or not these assumptions hold true. Okay? Non-linearity of the outcome, heteroskedasticity, presence of influential values, outliers, high leverage points. Okay, and isama na natin dito din, guys, yung omitted variable bias. Kind of include na lang. Omitted variable bias. Okay. So let's now go to our diagnostics. So gagamit tayo, guys, ng ito from base R to. Parse means partition. Partition, MF row, 2 by 2. Ibig sabihin ito, guys, na ang plot na i-create natin dapat 2 rows and 2 columns. Sila ibig sabihin yan. Okay, number of rows and columns, 2 rows and 2 columns. So sasabay natin to i-run. I-plot natin si MFIT1, yung model natin, tapos ipa-plot na yan sa 2 by 2. Okay, so let's run this, highlight this, run. Okay, so there you have it. Ito na yung unang plot natin ng mga ng analysis natin na residuals, guys. We'll explain this one by one. So you have residuals versus fitted. So sa y-axis yung residuals natin, sa x-axis yung predicted values natin. Okay, gagamitin natin to in order to determine linearity and also constancy of variance. Ito naman, guys, so normal QQ plot, we use this to determine if our residuals are normally distributed. Okay, ito ginagamit din natin to. Third one, yung ang y-axis natin is the square root of your standardized residuals. So take note, medyo kakaiba yung dito. It's a function of your residuals. So ang ginagawa dito, ini-standardize mo na yung residuals. You know what standardized residuals are? Diba yung standardized values is the value minus the average divided by the standardized deviation, diba? In other words, yung sa normalized values natin. And then kukunin pa yung square root. Okay, so ginagamit natin to, we'll discuss in a while, kung heteroskedastic yung errors natin. Dito, guys, dito, residuals versus leverage. This is used for leverage determining which are influential or highly leveraged. Kita niyo ito yung Cook's distance, no? Okay, so let's explain this one by one. Okay, nakuha ba guys muna? Were you able to plot this? Okay, thank you. All right, then there's another way to do this, ggplot2, no? Using the ggplot2 function and then autoplot. So, i-plot din natin to. Okay. So, pareho lang siya, no? Kaso nga lang, I like the print better. It's just the same as the plot function. Ito yung autoplot ng ggplot. It's just the same. Ang tagal mag-load. Ito na lang, guys, no? So it's just the same, guys. Only that I prefer the print. Okay, let me run this together. Okay, if I compare, guys, personally, guys, ako, mas preferred ko to. No? Okay, dito mas apparent, guys, tingnan nyo. Yung residuals dito, di ba? Kita nyo, medyo may fanning out. No? May fanning out siya. Okay, let's continue first. Okay, so we can use also another plot. There's this package, GG residual panel. Hindi pa ba natin sinawa dito? Did I include that here? GG residual panel. Wala. So paki-load muna to, guys. I-install that package just muna tong GG residual panel. Once you're done, guys, kindly chat, please. Okay na? Okay, good. So let me run this. Ay, wala siguro na install. So while it's loading sa akin, guys, no? So we're using the GG residual panel. This is related to ggplot, no? So from ggplot, guys, ang dami nang na generate na mga packages and functionalities na related sa ggplot2. So we're modeling fit1, plots natin tong mga Cook's distance, residual, histogram. This is for the histogram, yung number of bins, and then QQ bands, it's a normal QQ plot to, it's type standardized. Okay, so there. Okay, so this is another way, guys, to plot. Diba? Mas kompleto to dun kanina sa auto-plot natin. Okay, so andyan din yung QQ plot. Andito din, guys, yung standardized residuals at saka yung ito yung this is your actual data, sales, and your predicted values. Ito yung mga residuals natin, di ba? And then this is your Cook's distance, then this is your residual plot. So may mga plots dito na wala dun sa kanina, no? So we're trying to gather here as much information as possible from different packages in order to plot yung anything of, not everything, but most things about our residuals. Okay, then isa pa dito, guys. Here, the function is receive. Dito kasi, receive panel, anong difference nito? Let me check. Ito all, no? All. Ito kasi dinefine lang natin yung ano eh. So, guys, very good practice is to, hindi ko pinakita sa inyo, but this one, as usual, guys, yung functionality. Yung functionality, tingnan natin. Just check that. Yeah, okay. So this one, guys, the receive panel function is from the GG receive panel plot, creates a panel of residual diagnostic plots given a model. So ito na yan, guys. So pwede siyang LM, pwede siyang GLM, no? So and LME and GLM-ER model. So different models, guys. So GLM, gagamitin din natin yan. So take note, guys, na you can also plot residuals if our model is GLM. Kunyari sa logistic regression, GLM gagamitin natin dyan. Okay, so there are different types, no? Type of residuals using the plot. Plots. Okay, so dito yung una kasi natin dito, yung plots, define lang natin. No? So dito plots, asan si plots? Plots chosen. See details for the available option. So dito, guys, ito yung details niya. Options for plots. All, ibig sabihin ito yon. So my box plot, my Cook's distance, my histogram, my index, my location scale, my QQ plots, ito. No? A YVP, plot of observed versus predicted. Y is your actual data versus your predicted. So i-run natin to. Okay. So mas kompleto to, no? Okay, 9 all in all. Okay, so hindi tayo, guys, we're not at a loss. We're not lacking of tools to use when we do residual diagnostics. In fact, sobra-sobra nga yung natin, yung tools natin at our disposal, guys. Many tools, many residual plot tools that we can use in order to assess whether our model is okay or not based on residual analysis. So, ang ano na lang sa atin, ang challenge na lang, choose which of these are are important, or at least discuss them, no? And how they relate to either violations of the assumptions of the classical linear regression model. Okay, so titingnan natin ito isa-isa, no? Let's just take our time. Huwag natin i-rush to. Clear so far, guys? Clear so far? Chat, please. Clear so far yung plots natin. Okay, so yung iba hindi pa nag-respond. Guys, ito kailangan ko respond yung lahat, ha? Kailangan mag-respond kayo. How do you like, or how do you assess so far, guys, yung capability ng R based on what we have seen so far? Okay, of course, don't mind first yung the fact that hindi nyo alam i-code to, no? Okay lang yun, guys, kasi awash na yung internet ngayon ng ng information. So what you can do is type, kunyari, diagnostic plots in regression, but makakakita kayo ng maraming information. Now, you might not be able to understand at the moment kung ano yung code chunk na yun, but as you go along, guys, no? As you go along. So don't be too harsh on yourself by saying, ay, ano naman ito, napakahirap naman ito. It's okay, guys, it's okay. It takes time really, no? So, but andito yung process ng learning. So for example, ito, I don't really expect you, kasi hindi naman tayo nag-GG plot, no? Pero yung mga students ko na nag-FINTSAR sa akin, tapos nag-FINTSAR the following term, wala sa akin ng problema to kasi dinaanan talaga namin, no? Dinaanan namin. But the challenge for you guys is to, on your own, learn ggplot2 also. Okay, so how do you assess, guys, yung capability, yung capacity, and so far, your learning about R? Comment, please. How is it so far? Wala ba ko comment? Guys, hello. Kamusta naman? Kamusta naman ang R sa inyo so far?
Sir,
Yeah.
for me, I think R is actually pretty convenient in making plots compared to Excel because it's all consolidated. But at first sight,
Yeah.
R seems it seems hard to understand.
Yeah.
But
Oo.
once you learn about it, it will definitely help in future as well.
Thank you, Samir. Yeah, that's true. Tama yun. Yeah, very precisely said, no? Talaga may learning curve, guys. So you will have to invest, guys. That's why I'd like to encourage you. Huwag kayong mawawala ng ano, huwag kayong matatakot, guys. Kasi ah, lahat naman tayo dumaan sa ganun eh. I've been using R for 20 years na, guys. So kayo ilang weeks pa lang, no? So don't compare yourself with me kasi ako matagal ko na ginagamit sa R. So ako lang ang inaano ko lang ang sinishare ko lang sa inyo yung sabihin natin I had to do this, I had to share this with you itong code na to. Kasi yung output niya importante. So total you have that code. You don't have to understand that really that much now. But since you have that as information magagamit nyo yan, no? Magagamit yung code niya pag nagpa-plot kayo ng residuals. So later on, as you get used to it, then it becomes second And guys, never ending tong learning ng R. Ako, I don't memorize codes. Yung mga yung mga dapat lang i-memorize, yung mga katulad nito. Itong diagnostic codes na to, yung pag-plot, hindi ko memorize yan. Kasi alam ko meron akong copy niyan. So when I need it, I'll just get it, no? Unless guys, ang talagang nature ng work ko, ang nature ng ko is really plotting residuals, doon ang focus ko, then there are things that I need to memorize. Pero kung hindi naman, yeah. Thank you, Samir, for that comment. Sige, tingnan ko lang yung ibang comments, ha. Okay, let's see. Sabi ni Mariel, thank you for your comment. It's intimidating at first, but when you look at it once, ang familiarize na po kayo. Okay, yes, that's true, no? Very useful talaga siya. And yeah, intimidating and yung learning curve, medyo may pagka-steep na learning curve. But guys, we have to start somewhere, di ba? And now is the time to start somewhere. It's more convenient, thank you, but harder to make. Yes, no? Harder to make kasi nagsisimula pa lang kayo, guys. Pero tingnan nyo, guys, with just this line of code, di ba? Ito lang. In-access lang natin si GG receive panel. Tapos, sabi lang natin, we use this function receive panel, and then ginamit lang natin yung model natin si fit1, and then sinabi lang natin na plots, isama na niya lahat, no? Pins 30, this is for your normal distribution. Smoother is equal to true. Dito sa mga, yung smooth lines, guys, ito yun. Yung mga lines na hindi straight line. QQ bands, that's for your QQ plot. Ito, yung bands, yung parang gray na yan. Yung parang lower and higher points niya. And then type is equal to standardized. In some plots, gagawin din yung standardized values. So just with this very small code chunk, isa nga lang eh. Kasi itong library, hindi naman kasama talaga dito yan. So take a look at the output, di ba? It's really more convenient and the output can be very amazing. Guys, ewan ko guys kung hindi kayo na-amaze dito sa output na to. Pero when I first did this, matagal na, no? I was really amazed, guys. Yeah, you're correct. Harder to make at first. Yeah, thank you. I'm sure all of you can attest to that. Nakaka-amaze naman to, grabe. I'm still having a hard time with understanding, yes. Thank you, Steph. Steph, paki-share naman yung yung share mo sa akin sa lab. Steph, can you please share your chat sa lahat, please? Kasi I'm sure everyone really connects with this. Having a hard time, that's true, with understanding the process. Okay, so guys, hindi nyo naman kailangan i-memorize, no? Kasi andyan na yan, you can just use that. Parang lang siya, parang nasa toolbox nyo lang. You don't have to really memorize all the tricks of the trade, but it's there, available for your use. And if you need others, guys, andan naman si www, guys. Ang dami na kasing gumagawa din ito, ang dami ng nagsishare sila ng nila, experiences, nagsishare sila ng So we are, it's free to tap into that wealth of resources. So that's the good thing about this. No? Unlike dati guys, nung wala pang internet, when I was learning this, hindi pa masyadong yung internet eh. So, mas mahirap, no? Pero ngayon, guys, madali na, no? It's really easy. All right, so we'll be taking a look at some of the, at what this means, no? Ano yung mga ibig sabihin nito. Okay, sige guys, would you want to have a, bago tayo, before we dive into this, would you want to have a few minute break, guys? 10-minute break muna. Okay lang ba? Water break, short break. Okay, sige. For those of you who want to catch up to, baka yung iba hindi pa napaplat, just do that now. Or water break tayo, guys. Whatever, no? In 10 minutes, 9:45 sa clock ko. So let's magkaiba dito sa isang clock ko, 9:48 dito. So basta in 10 minutes, guys. So 9:45, 9:55. Let's be back, no? Sige. Pause ko muna yung recording. Please remind me, guys. So these plots are very helpful in determining or in assessing whether our regression model violates the assumptions of linearity, normality, constant variance, which is homoskedasticity. So we're going to use these plots to assess a regression model. So the diagnostics plots, yung 4 different ways, ito yun, no? Ito, no? That's what I meant by the 4 different ways. Dito kasi 9, but all of them are, of course, related, no? Related naman sila. Kasi itong, for example, itong QQ plot at saka histogram. Okay. Pareho lang yung sinasabi niya, no? Ito naman, box plot, pinapakita dito outliers. You have the Cook's distance to determine if there are influential data points or leverage points. Okay, and then these are plots that that will indicate a constancy of variance. Okay, so as regards the 4 plots above, first is your residuals versus your fitted. So dito, ito yun, di ba? It plots your residuals and your fitted values, predicted values and your residuals. So what does this indicate? Okay, para mas guys, dali let me copy this. Control C. Let me copy this here. Para hindi ako, I don't go up and down, up and down. I don't keep on Control V. Ay, sorry, Control Z. Saan na yun? Kinakopy ko lang ito. Ito lang. Control C. Just that one. Kasi gusto ko lang yung plot malapit dito sa discussion dito. Ano nangyari? Okay. Kasi hindi ko na-close. No? Yeah, I should have just copied the code itself. Okay, let me run this. That way, guys, malapit siya sa discussion points natin. Okay, there. There you go. Okay, sabi dito, guys, residuals versus fitted. Ito yan, no? This is the plot of your residuals versus your fitted values. I hope by now, guys, clear na sa atin yung terminologies natin. Yung fitted values, these are your predicted values. No? So paano siya nakuha? It was determined by using the model and substituting the values of your predictors to arrive at your forecasted or predicted value. And then residuals, yung difference ng predicted value at saka ng actual value. So, saan ginagamit yung residuals versus fitted? it's used to check linear relationship assumptions. Okay, linear relationship ng ano? Linear relationship ng, di ba, ng variables natin. Okay, we want the independent and the dependent variables to be linearly related. So if you take a look at this one, parang wala namang masyadong deviation. Okay, so it looks like our ang ano natin, ang dependent at saka independent variable natin are linearly related. Of course, there are other ways you can do the correlation itself. Diba? Pwede natin kunin yung correlation measure. Number 2, ito, normal QQ. QQ, by the way, stands for quantile-quantile. Normal quantile-quantile plot. So what's this used for? It's used to examine whether the residuals are normally distributed. It's good if residual points, residual points follow the straight dashed line. Okay, so if the residuals do not deviate so much from this one, okay, okay tayo. We don't want a J-curve, parang J-curve na residuals or an inverted J-curve. We want the residuals, especially here, no? Sa portion na to. Not so much dun sa tail end, but especially here, sa mga portion na to. We want the residuals to be, to behave near this dash line here. Okay, number 4, yung scale location or spread location. So it's used to check the homogeneity of the variance of the residuals, or ito yung homoskedasticity natin. Horizontal line with equally spread points is a good indication of homoskedasticity. Yan. Pag horizontal siya, guys, okay, horizontal line, guys, with equally spread points is a good indication of homoskedasticity. In our example, guys, hindi, no? Medyo hindi siya. Okay, if we're looking at the standardized residuals and the fitted values, notice, guys, may ano, no, may fanning, parang across the fitted values, lumalaki yung ano natin, yung residuals, yung range, yung standardized residuals natin. So, and the red line here is not horizontal. So this is indicative na possibly ang medyo yung residuals natin are not constant. So they're not homoskedastic, they are instead heteroskedastic. Okay, and then we have here residuals versus the leverage points. Asan na siya? Residuals versus the leverage points. Ito. Tapos may Cook's distance tayo nakalagay dyan, no? Which will explain also. Okay, it's used to identify influential cases. These are extreme values that might influence the regression results when excluded from the analysis. No? This plot will be described, okay, they'll describe natin in the next sessions. So the 4 plots show the top 3 most extreme data points. Okay, sandali let me highlight this. Let me maximize yung okay, if you can see here, guys, may mga numbers dito, no? Hindi lang masyadong kita dito eh. But this is 179. This is also 179. This is also 179. This is 179, 26, 36. So these are outliers, or these are possible influential data points. So linalagay niya. This is 36, yung 36 mo ba? Yung 20, 26 din. 26, 36, and 179. So dito sa plots na to, kahit dito, kita nyo 179. It shows here values that are outliers, okay, and possible influential data points. Okay. All right. So you can plot them, guys. Yung sa plot natin, pwedeng isa-isa siya. No? So tingnan mo natin isa ito, no? So plot FIT1 number 1. So this is the first plot. So this will now plot it individually para mas makita natin if you want to really see it more. So dito mas klaro ano? So you can see here that the line seems to be medyo straight naman siya, no? Actually, this can also show yung hindi lang yung linearity of the data. No? Mukhang straight line naman siya on the average, but it can also show here yung first ano natin, yung residuals versus fitted. Yung residuals natin kung homoskedastic siya. Kita nyo guys, medyo may fanning out, di ba? Across the fitted values, lumalaki yung range ng residuals natin. So, although linear yung relationship ni sales at saka ni YouTube, this plot also indicates that the residuals are not constant. So we have non-constancy of residuals. Then you can also plot number 2, number 3. So tingnan natin guys si number 3 kasi pinapakita dito sa scale location point yung variance natin. Okay, so here you can see, diba? So bigger scale, mas kita natin. Kasi yung kanina yung lahat, dito mas kita natin si 26. Again, dito itong tatlong influential points or outliers. No? And you notice that yung line na to, dapat straight line to eh. Dito sa scale location. In order for us to infer that the error terms, the residuals are constant. Pero hindi siya mukhang constant, di ba? And that's shown by this red line, yung trend niya. Medyo umaakyat, ibig sabihin increasing across the values of your fitted values. Okay, so I think meron pang guys meron pang tingnan natin comments natin dito. This plot shows if residuals are spread equally along the ranges of predictors. It's good if you can see a horizontal line with equally spread points. In our example, this is not the case. You can see that the variance of the residual plots are increasing over the time. So this is indicative that we have heteroskedasticity. Okay, so let me check kasi alam ko may number 5 po to eh. Okay, so dito lang, no? Singit ko lang to guys, ha? Dito lang. I know my fifth plot siya na okay. Ito yung number 5. Yung number 4 sa taas. Yung number 4 dito guys, saan natin. This is actually number 5. Ibig sabihin may fourth one. Nakuha nyo guys, yung pinat ko yung number 5, plot number 5, ang lumabas yung fourth. No? Ibig sabihin there's a number 4. Number 4 natin, I think this is the Cox distance. Yan, okay? Alright, so yung pinaplot talaga dun guys sa dun sa plot function natin, hindi siya 4 lang. So, ano nga natin to guys, palitan natin, tingnan natin kung lalabas yung number. So let's make this three rows by 2 columns. Let me check. Hindi siya pinat, ano? Hindi, I don't know if it's hindi lang siya nagkakasya or let me make it, oops, let me make it 2 by 3. Let's see if this will work. Kasi meron pa siyang isang plot eh. Ayan, 4 lang talaga. So you have to draw it out guys by so ibalik ko na lang to sa 2. Okay. And then merong number 4, no? Merong 5th one which is actually the 4th. Ito yung Cook's distance. All right. So ilagay ko na lang to as a note, no? Lagay nyo lang din as a note, guys. Saan natin ilalagay? Pwede yung ilagay dito. Ito na lang, no? Actually, there are 5 plots that can be generated. For your notes, guys, no? Ilagay kayo notes para alam nyo. So 1, 2, 3, 4. And then 5. So hindi lang 4 yung ma-generate niya. 5 yan. No? Okay, so let's go back here. Now, later on, we're going to discuss yung remedies. Kasi ngayon, tinitingnan lang natin kung linear ba yung relationship ng variables natin, kung meron ba tayong equal constant variance, okay, kung may outliers ba tayo, etc. So, ito, guys, no? A possible solution, although I went ahead of myself already here, a possible solution to reduce heteroskedasticity is to transform your data. Okay, pwede nating i-log or square root yung y variable natin. But we'll look at that next time. No? Okay. So now may mga guys, may mga hypothesis, may mga statistical test. No? Hindi lang importante yung plots. No? These are very important because we can draw out several much information about this. Kunyari itong may mga common, di ba, na may mga plots dito na andun din sa sa plot natin, no? Di ba meron tayong 5 doon? Meron tayong itong standardized residuals predicted, andun siya. 2, 3, 4, 5. So 1, 2, 3, 4, 5. Itong tatlong nasa baba, tsaka yung unang dalawa, they are present there in the plot function. Ang nadagdag dito, guys, ito, no? Ito. Itong 4 na to, which cannot be seen in the plot function. Okay, so this is just a plot of your response variable and your predicted values. Okay, again, this will can be used to reinforce yung constancy ng variance ng residuals natin. Ito naman, di ba, this asan yung QQ plot? Ito pala. Sorry guys. 1, 2, 3, and then 1, 2, 3, 4, 5. Apologies guys. Walang index plot, no? Dun sa 5. Itong apat na to, I stand corrected guys, itong apat na to, this one, the index plot, response versus predicted, histogram, and box plot, these were not present dun sa ano, sa plots natin. Itong limang to yung present. Okay? So dito makikita natin guys yung presence ng outliers. Ito, may dalawa dito. This could be 179 or 26 or 36. Hindi nga lang nakalagay dito. Okay, pause muna ako guys. Clear so far. I just went back to this one just to compare ano yung difference ng dun sa GG Resid panel at saka dun sa plots lang mismo. Any questions? Okay, good. The others guys, clear ba? Okay. All right, so let's go back here. So the plots guys have their own use. They have their own place sa residual analysis. It's really impossible guys to do a good residual analysis without the plots. Dapat may plots. But the plots should be coupled with statistical analysis. So for example, when we're testing for constancy of variance, remember guys, yung homoskedastic means constant variance. Constant yung spreading out ng residuals natin. There are several tests to do this. One is the non-constant variance test. Ito yun. Non-constant variance test. NCV test. Okay? So this test comes from the comprehensive applied regression SCAR package. Okay? So it's used to evaluate homoskedasticity or the non-constant error variance test. Ang null hypothesis natin dito, the variance of the residuals is constant. Okay? So ibig sabihin, we want the p-value to be greater than 0.05 so that we will not be rejecting the null hypothesis. Pag reject natin yung null hypothesis, which means the p-value is less than 0.05, then it means na heteroskedastic yung ano natin, yung residuals natin. So, narana ba natin yung car? I think nasama na natin si car. Wala, no? So, kindly install first si car package, library car. Okay, and then once you have installed it, i-library nyo, and then i-run natin to. So, I'll just run this first. Naran nyo na guys, nag-run po sa akin. Ba't ang tagal? So, nag-run na sa inyo guys. Feedback please. Hindi nag-run na. Okay. Run po ulit. Pa rin. Yes, good. Nag-run sa akin, ayaw pa rin. Tanggalin ko na tong card dito para library. Install ko muna yung library, guys. Akala ko na-install ko na kanina. Kaya siguro nagka-problem ako. Okay, then this one. Yan, guys. So we have now the non-constant variance test. No? So it uses a chi-square test and the p-value is less than 0.05. So this tells us that yung residuals natin, they are not constant. As expected, kita naman natin sa plots. No? We can see in the plots that the residuals were non-constant. Okay, so clear to guys, using the NCV function from the car package. There are other tests, si Bruce Pagan test. No? So this is the BP test. This is from the LM test package. So similar guys sa similar dun sa NCV test, our null hypothesis is that the residuals are constant. So we would want the p-value to be greater than 0.05. So pag rinan natin to, usually guys, it will, pareho din, no? Pareho. We reject the null hypothesis that the residuals are constant. And there's a third one. Okay, hindi. Okay na yun. No? So, yung BP test actually guys, kasi minsan there are rare naman nagkakaroon ng ng conflict dun sa conclusion. Okay? Iba kasi iba yung manner ng testing ni Bruce Pagan test. So, I just wanted to point out that the BP test, this one, is more robust than the NCV test. Kasi ang difference nila sa BP test, ang tinetest natin yung studentized na residuals. Sa NCV, yung residuals. Okay? So, bakit kaya mas maganda kung naka-studentized? Okay, so this is coming from this writer Conker. Sabi niya, the asymptotic power of the BP test is extremely sensitive to the kurtosis of the distribution of your error terms, and the asymptotic size of the test is correct only in special case of Gaussian kurtosis. So may reason siya kung bakit ang sabi niya mas maganda kung mas powerful yung BP test, no? But guys, okay lang naman na parehong gamitin. Just as a reinforcement. Wala namang problema doon. Okay? So maglagay nga tayo dito ng maglagay tayo dito ng hindi ko nalagay yung statistical test. Okay. So statistical test na tayo, no? Sorry, I forgot to put the heading. Yung una dito, our number one here is test for constancy of variance. Kung homoskedastic yung error terms natin. Okay. Now, number two natin, guys. Test for the normality of residuals. Okay. So sabi natin guys, yung sa normality of residuals, we can use the QQ plot, di ba? Yung quantile plot natin. Saan yung quantile plot natin? Ito pala, no? Sinulat ko na pala dito. Number 2 siya, no? Number 2. So habang nag-load siya, yan. No? Ito yung normal quantile plot natin. Sabi natin guys, dapat as much as possible, very close to the straight line dito. No? And you can see here, ito na naman si 179, si 36, at saka si 26. Okay. So, the QQ plot can be used to visually check normality assumption. Okay. So mukhang normal naman siya. No? Wala nang masyadong malaking deviation from the QQ quantile line natin. No? But we're going to use statistical test. So combination ng visual at saka ng statistical test natin. Okay, so using the stats package, we're going to make use of the Shapiro.test function. And then, itetest natin yung residuals natin ng model natin na FIT1. We're going to run this. Okay. So here, the null hypothesis is that the residuals are normally distributed. And p-value here is 0.2133, which is, so we are able to not reject, no? We fail to reject that the residuals are normally distributed. So wala tayong problema dun sa normality ng residuals. The residuals are normally distributed. Okay. So next guys, yung outliers at saka yung high leverage points. So dito dinefine ko guys yung kung ano yung outlier, tsaka kung ano yung high leverage points, at saka kung ano yung influential points. What's an outlier? A point that has an extreme outcome variable value. Okay, so yung presence ng outliers, guys, may affect the interpretation of the model because it increases the root RSE, root mean square error to. No? So outliers can be identified by examining the standardized residuals, which is the residuals divided by the estimated standard error. Okay, so may mga points lang dito guys na which I leave you to read. Ganun din si high leverage points. Extreme predictor X values 2. So si outlier guys, dali lang guys, inom lang ako. Okay. High leverage points. May formula, guys, there's a formula that they use in determining whether a point is high leverage points. So hindi natin titinan kung paano kinocompute yan. Just be aware, guys, that there's such a thing as outliers, influential points, at saka yung leverage points, at saka high leverage outliers, leverage, at saka influential data points. So let's run this. Ito yung residuals versus leverage natin. So how is this interpreted? Okay. So na-interpret siya guys dito. Dito sa mga ito. Kanina pinapakita ko. Okay. Ito. Tapos hindi masyadong kita dito yung ano, yung there's a better plot to determine the Cook's distance, which is yung number 4. So ilagay din natin dito guys. Although diniscuss yata siya dito. Yan, ito pala, sorry ha. Okay. Pinasok ko na pala dito. Okay, so let's not bother guys with how this is computed. No? Basta, what's important to realize, what's important to understand is that yung mga outliers na to, at saka yung mga leverage, we should be worried about this. Kung nag-identify ng outliers, not so much with the outliers. Mas critical yung leverage, and pinaka-critical yung yung influential data points. No? All right. Not all outliers, guys, are influential data points. Not all outliers are leverage. Pero lahat ng influential data points, lahat ng leverage, guys, are outliers. Okay? So kunyari, meron kang 10 outliers. Maybe just one will be an influential data point. That influential data point definitely is an outlier. Okay? But not all outliers are influential or leverage. And again, guys, may way to compute yung Cook's distance. Okay, but we will not go into the computation. We will let the software itself compute the influential data points for us. So here we're plotting number 4 and number 5 simultaneously. Inulit lang yung number 5 kanina. And you can see here the Cook's distance. Ito. Okay. So ito guys yung ito yung mga possible candidate for influential data points. No? 26, 36, and 179. Okay. The top 3 most extreme values sa default sa plot are labeled on the Cook's distance plot. Kung gusto natin yung top 5 extreme values, then sasama natin itong id.n is equal to 5. So ito top 5 daw to. So let's plot this, yung top 5. Okay, so kasama si 132 at saka si 176. Pero may cut-off usually yan guys. No? May cut-off yan. It doesn't mean na, kunyari, ilagay mo nga yung top 10 na mataas yung influential niya. Okay, ilalagay yung top 10. But not all of them are influential data points. Kasi may cut-off point na ginagamit si Cook's. No? Pero pwede lang natin ilagay dito kung sino yung pinaka matataas na Cook's distance. Okay, so we're just interested in ito yung top 5 kanina. Kasi ang default 3. Okay, so ito guys, if you recall, di ba may object tayo ng model.diag.metrics. And then, remember this, and then top n natin, top 3. No? Weight WT is equal to yung dot Cook's distance. So let's run this. Okay. So it printed to us guys, coming from yung model.diagnostics.metrics natin. We recall this guys. We recall this data frame. Diba, andyan si sales, si YouTube, tapos yung fitted, yung residual, andito si Cook's distance. So what we did was to use this data and then kunin niya yung top 3. Top 3 para malaman natin kung anong point yun. Kasi ang linalagay lang niya, number 36, number 26. So, what were those data actually? Ito yun. Yung sales na 14.4, diba? Sales na 15.36 at saka sales na 14.66. So let's check muna, no? Si marketing. Asa na si 26? Ito yung number 26. Kasi yung tatlong lumalabas yun, di ba? 26, 36. Ito yung 23.4. Yun. 23.4. Wait, parang hindi ah. Yung number, ilang guys ha, let me see. Dun sa model.diag.metrics, number 26. Okay, is this, wait lang, 26.52 should be the same. Ay, wait. Mali tinitingnan ko. Dali. Sales is 26.52. Nabago guys. Sorry nabago yung order. YouTube 276.12. YouTube. Tama, pareho din. 276.12. Okay, hinahanap ko lang siya guys, sorry. So, basta ito guys yung mga points natin na top 3. No? Unfortunately, hindi niya linagay kung anong index to. Hinahanap ko siya, kasi ang lumalabas, di ba, yung 26, 36, at saka yung 179. So, paano in-arrange to? By Cook's distance, 0.03, 0.06, hindi rin siya in order, no? Hindi siya in order. Okay, anyway guys, so that can be checked naman kung asan yung mga points na yon. Okay, so let's move on. Now, OLSRR package also has other uses. Hindi lang yung stepwise regression. So let's take a look at this. Pwede din natin gamitin si OLSRR para i-plot yung Cook's distance. Okay? So ito guys, di ba ginamit natin OLSRR for stepwise? Maraming functionalities ang OLSRR. Another one is sa diagnostic, sa regression diagnostic. So let's run this. Okay, let's wait for the results. Tagal. Nagrana sa inyo guys? Buti sa inyo, ang bilis. Sa akin, ang tagal. Okay, while it's running, guys, I'm taking stock of the time. Now, kindly please, okay, as your assignment, okay, i-run nyo to guys, ha. I'm sure, kung kailan man tayo mag-meet, guys, we'll have to decide on that in a few minutes, no? I-run nyo to. Yan na. Okay. All right. So, what do we find here, guys? Cook's distance, no? Yung mga red, mga outlier. Yung mga blue, normal. Okay, nagsabi lang siya na ang default na cutoff is 0.02. So marami siyang threshold, no? 0.02. Marami siyang na-identify na outlier. But we still have to determine, guys, kung not all of them are influence points, no? Are influential points. Okay, this is another way to plot it. Ganun din siya, no? But this one is in chart form. Okay, then this one, it's a panel of plots to detect influential observations using DF betas. Kasi guys, maraming methods in order to determine influential observations. Now, we need to determine influential observations kasi pwede maka-affect ng model natin yan. Okay, so let's run this. Ito hindi ko na i-run, pareho lang naman yan ng una. However, this is in chart form. Sige na nga, i-run ko na para makita na lang din natin. Okay, yun ba yun? Wait. Did I run that? Dali lang, ha? Hindi naman chart form to eh. Parang mali yung code ko dito. Okay, but let me just check. Okay, chart form according to OLSRR. Ito yung chart form yan. I was expecting a table, pero hindi rin. So the same lang siya dun sa una. Then let's run this yung DF betas tapos yung DF fits. Sabay na natin i-run. Kasi these are two ways by which you can identify ano yung mga ano yung mga influential data points. Okay, so using DF fits and DF betas, okay. So we have possible candidates using the DF fits. No? Ito yung mga possible candidates. Yung 179, bukod tangi guys, no? At saka itong 36, at saka yung 26. Yung iba guys, very close. No? Okay, that's why others will use a different threshold. Yung iba gagamit ng ibang threshold. Kasi we can actually check, no? Kung tanggalin kaya natin tong 0.37 na to, magiging malaki ba yung difference kung sa parameters? Chances are guys hindi. Kasi medyo conservative yung 0.2 at saka negative 0.2. So others would use a higher cutoff. So baka 0.1, 0.2, maybe 0.3 kung 0.3. So hindi lahat papasok talaga. Ito mga iba dito 184, 1 barely lang sila, no? Barely sila nagka-cut dun sa sa threshold na na cut-off point. So we should use this with caution. Ang gamit nito guys is pag na-identify na natin influential data point, tingnan natin. So what if we remove this? What if we remove this influential data point and then run the regression? Would this affect greatly your regression outputs? So that's what the Cook's distance measures and the influential data points. Okay, so we leave that first for a while, guys. We're going to continue with this, but this time, ito guys, pakisimulan yung gawin ha. Ito, no? Fit 2. This time, kasi simple regression lang tayo kanina. Yung i-discuss natin, gagamitin na natin lahat. No? Yung YouTube, yung Facebook, at saka si Messenger. And then, As an exercise, guys, iran nyo ulit yung diagnostics. Tingnan nyo ulit, i-plot nyo, and then statistical test. Now, this time, may dinagdag ako dito. Ano yung dinagdag ko? Multicollinearity. Kasi sa taas, walang multicollinearity. Kasi simple linear regression lang yun. Ito ngayon, multicollinearity, it's to test whether multicollinear yung mga predictors natin. Okay, here we're going to use the variance inflation factor. Okay, it comes from the CAR package and you can use this test. Okay, and then lastly here, yung huli guys, isa pang test is the omitted variable bias test. This is another test that we use for regression diagnostic. It makes use of the reset Ramsey regression equation specification error test, yung reset. No? And we'll explain this next meeting. Itong mga to. No? And medyo may ma-introduce tayong panibagong mga concept, yung interaction variables dito. Okay, we haven't discussed this. And then ito yung sinasabi ko sa yung kanina guys. May mga violations which we can readily address. No? May mga hindi. No? But don't panic if your diagnostics aren't perfect. The good news about regression is that it is quite a robust technique. It will often give us a reasonable answers, no? Even when the assumptions are not perfectly fulfilled. Ang kailangan lang aware tayo ng mga assumptions, no? But we should not become too obsessed by them. If the violations are modest, it's okay to proceed. We just need to interpret the results with care. Okay, of course, we have to know what constitutes a modest violation. Ang problema nito, wala namang cast in stone na hard and fast rules on that. No? So it's something that you do through judgment. And syempre, kunyari, kung economist ka, tas you've been doing modeling for X years. So alam mo may violation ng heteroskedasticity. Pero kung titignan ko yung plot, hindi naman ganun ka Statistically, may violation. Pero sa plots naman, hindi naman ganun ka So okay lang yan. No? So it comes with experience. So since on your end, wala din experience, di ba? So okay lang guys, it's important for us to identify lang na may problema sa heteroskedasticity, okay? And yung mga kaya natin na i-settle, kunyari, yung homoskedasticity na problema, yung error terms, madali nang maano yan guys ngayon. Kasi may mga robust models na that can be used. Okay? So sa heteroskedasticity, not much of a problem now. Saan pa? Multicollinearity. Mas madali actually yun. Kasi magtatanggal ka lang ng isang variable na multicollinear dun sa isa. So that leaves us with not so much, wala na masyado. Normality, hindi na masyadong problema yung normality. No? Okay, so let me end our discussion there. Okay, so let me pause, let me stop recording now.